This is Note Taking Guide 4.6 for Mathematical Decision Making for Life. Today we're going to talk about using volume and area. So it says an ice cube tray can make 14 ice cubes. If the length of each cube is 2 inches, what is the total volume of the ice in the tray? So we know it's a cube, you guys, which means each ice cube is going to be 2 by 2 by 2. So 2 by 2 by 2 would be the volume of one ice cube. So 2 times 2 is 4, 4 times 2 is 8. So the volume of one ice cube is 8. They said that there was 14 ice cubes there. So I'm going to go 14 times 8, and I'm going to get a total of 112. So the volume of the ice cubes is 112 inches cubed. Okay. Now we're going to go on to a pop can. A pop can holds 502.4 centimeters cubed of pop. If the radius of the can is 4 centimeters, what is the height of the can? Well, the volume of a cylinder formula is pi r squared h. I was given the volume, which is 102.4. I was given the height, which is 4. Oh wait, nope, I'm looking for the height. I was given the radius, which is 4. I'm sorry. So I'm going to change that r right there to a 4. And then I'm looking for the height. So just over here, why don't we figure out what pi times 4 squared is so that we can just kind of do the math. So we have pi times 4 squared, which gives me 50.26. So on that side, I have 50.26. On the other side, I have 502.4. So to get the height by itself, I'm just going to divide by 50.26. And when I did that, I got 9.99, which probably could be rounded to the number 10. Because it's just the height, it's just going to be centimeters. It won't have a squared or a cubed on top of that. Okay, the next one says put these 3 ice cream treats in order from greatest volume to least volume. So in order to do that, you guys, I am going to have to find the volume of each one. So on the top here, we're going to have to find the volume of the sphere and then the volume of the cone and add it together. So let's do the cone first. The cone is 1/3 pi r squared h. That's the formula for the volume of a cone. So I'm going to go 1/3 times pi. The radius is going to be half of that. So it's going to be times 2 squared times the height, which is 6. When I punch that into my calculator, that's going to give me the volume of just the ice cream cone itself. So I'm going to do 1/3 times pi times 2 squared times h, and get that in our calculators. When I did that, I got 8 pi, which is the number 25.13. Okay, so that's the cone. Now I need to do the ice cream on the top, which is the sphere. The sphere's formula is 4/3 pi r cubed. So I'm going to go 4/3 times pi. The radius is still 2, and so I'm going to do 2 cubed. Sorry, I should have moved my paper so you can see that. So let's punch that in the calculator. When I do that, I get 33.51. So to find the whole volume of that, I'm going to do 25.13 plus 33.51. And when I do that, I get 58.64. Now that one's going to be the hardest volume that we have to find on these. The other two are just one shape, but the ice cream cone was 2 shapes added together. So we had to use the 2 shapes. So here's my volume of that ice cream cone. Okay, the push-up pop over here, it is just a cylinder. The formula for the volume of the cylinder is pi r squared h. So we're going to go pi times the radius. The radius here is again just 2. So pi times the radius squared times the height, which is 6. I'm going to punch that in my calculator. So I go pi times radius squared times 6. I get 24 pi. And when I punch the arrows to get me the decimal point number, it's 75.398. So I should probably round that to 75.40. And then the next one, this is just a prism. So I'm going to do the formula length times width times height. So 6 times 4 times 4. 6 times 4 times 4 is 96. So which one of these has the most ice cream? This one. It says put these ice cream treats in order from from greatest to least. So greatest would be the ice cream sandwich. That's number 1. Number 2 would be the push pop. And number 3 would be the cone. Now you guys, why did that happen the way that it did? Well, let's talk about this realistically. This ice cream sandwich is 4 inches tall. I've never had an ice cream sandwich that's that tall before, but that would explain why this ice cream sandwich is so big. Normally ice cream sandwiches are like an inch. So it's like stacking 4 ice cream sandwiches on top of each other to get that. So in this picture, these numbers probably don't represent clearly what the ice cream sandwich would look like in real life, where these are probably a little more accurate, but I don't think I've ever had a push pop either that's 4 inches wide. So got to watch your numbers here. Okay, next question here. We're taking 3 identical tanks, and the spheres in a given tank are the same size and packed wall to wall. If the tanks are filled to the top with water, then which tank would contain the most water? Assume the sides of the cube is 100 centimeters. So if the sides of the cube is 100 centimeters, then this would be 10 by 10, which means the radius of this big one would be 5. So that sphere would be 4/3 pi r cubed, and there's only one of them. So that would be 4/3. I'm sorry, let me say this again. Assume the side of the cube is 100. Somehow I left a number off of there, which means my radius is 50. I made that mistake. 100 times 100, and then the radius would be 50. So 4/3 pi times 50 cubed. When I do that math, I get a really large number for the volume of that cube. Okay. Now this time, you guys, I have to find the volume of all of these balls. So how many of them are there? There's 8 balls. So whatever I get, I'm going to times by 8. Okay. Still, the formula is 4/3 pi r cubed. So the only thing I need to know is what the radius is. So if it was 50 from halfway to there, then this new radius is going to be 25 because it will be half of that. So whatever I get here, I'm going to times by 8 because there's 8 of those balls. So you do 4/3 pi r cubed, and the r is 25. When I do that, let me just punch it in real fast. Let's see, 25 cubed. I get 65449.84. I have to times that by 8 to get 523,598.77. I need to check this one and see if I punched that in right, you guys. It doesn't look, it looks like I might have made a mistake. 4/3 pi, I think I put radius squared instead of radius cubed. I do that all of the time. I did, you guys. I punched the wrong number in right there. This is actually 523,598. They were supposed to be the same. I knew they were supposed to, so I could tell by the problem. So you guys, I punched in the number wrong here. So if you punched that in your calculator and you got this other number, you were correct. I'm sorry about that. So what do you think about this third one? Do you think that it will also be the same volume on those? It's what we're trying to figure out here. So this time the only thing that changes is the number of balls, and our radius again changes again. This time our radius is 12.5 because we took the 25 and we divided it by 2 again. This time how many balls are there? This is 4 by 4. So by 4. So 4 by 4 by 4 is actually 64 balls. So we're going to take 64 and times it by the volume of that. The volume is going to be 4/3 pi r cubed. And we're still timesing that by 64. Guess what? When I do that on my calculator, I get the exact same number. Because no matter what, those were the same. So that's kind of a funky problem to look at. It looks like there's more space in these other ones, but there's not. They're all the same volume. Okay, this next problem says, an interesting geometric problem is that maximizing the area enclosed by a rectangle with a given perimeter. Specifically, suppose you were given 100 feet of fencing and were asked to build a regular enclosure with maximum area. What shape of a triangle would you choose to do that? Well, this is kind of similar to what we did the other day, but I want to kind of just list what we could do here. So we're given 100 feet of fence, you guys, and I'm just going to switch over to this other for just a minute. I actually went through and I listed out every possibility of how I could use 100 feet of fence. I could do 1 times 49, because what that means is that around my rectangle, I would be 1 this way, 49 this way, and 49 this way. So the actual amount of fencing that I used is 100 feet of fencing. I could do 2 times 48, I could do 3 times 47, I could do all of these different possibilities. So then what I did with those was I found the areas of those. So I started multiplying them together. I knew that these first few right here weren't going to be the bigger ones, so I started in the middle. And then I realized once I got to a certain point, I would start repeating again. Once I get to 25 times 25, the next one would be 26 times 24, which is the repeat of that one. So I listed them all out of what I could have for dimensions, and then I just multiplied them together to find the areas. So the biggest area on this is that one that's smack dab in the middle this time, which is the 25 by 25, which gives me 625 square feet of area. So again, what we're going to do is we're just going to list out until we can figure out what we're doing here, okay? The next problem is another maximizing area problem. It says a farmer has 1,600 yards of fencing to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? You guys, 1,600 yards, that's too much to just guess and check with. So I'm going to let you just make some big guesses. I'm going to go right to the middle though, because I think if I divide this 4 equal ways, I could do 400, 400, 400, and 400. If I do 400 by 400, then that adds to the 1,600 yards of fencing. And 400 times 400 is going to give me 160,000 square feet of area. So let's just say that we didn't do 400 by 400, and let's just go one the other direction and see. Let's say we went 399 here, which makes this 401 and 401. So 399 times 401 is actually smaller than that other one. Okay, so we know that that middle one, just like we said right here, that on the example that I was just showing you, that the middle one gave us the biggest area. The same thing happens on this one. That middle one gives us the biggest area. So we know that the biggest one we want to do is that 400 by 400 rectangle there. Thanks for watching, you guys. Good luck with your homework.